Hello and welcome to Beginner's Python and Machine Learning. Today we're going to be looking at an introduction to Mongo database, and so we're going to use we're going to do it all online. So you don't need to have Python installed on your computer. You just need a Google account that'll let you get into Colab, and a Mongo DB account so that you can create your own Mongo database online. I think my software is running a little bit slowly today for some reason, but hopefully it'll be fine. So on Google, YouTube, and on the Meetup page, I've put a link to the Colab notebook. So if you want to click on that link, that should take you straight to the shared notebook that we're all going to use. Just let me know if there's any problems with the transmission, because everything seems to be going very slowly here. And while it's going, I've also posted instructions on YouTube on how to set up your Mongo DB. And that was to take you to the web page at MongoDB, and I've clicked on sign on, and that's taken me to here. And so I've put in a username and password that I made up, and we're just going to set up. So this is what you need to do. Hopefully you've already done it. I'll just click Python here and continue. And they run MongoDB in a cloud for us. We're just going to go for the free one. So we're going to create a cluster. Now what a cluster is a group of databases that enable you to have high availability. So I'll click on create a cluster, because that'll actually take a bit of time. And no, my web page is still loading. And a cluster is a group of databases, and they're all going to have the same data in it. So it means that any one database server can go down, and the other ones will stay available. So when it's reading data out of the database, it only just needs to read stuff out of the nearest one and return the results to you. When it's writing data to the database, it has to make sure when it writes to one, it also writes to all the others. So writing operations are a bit slower, but reading can be very fast in a cluster situation. So I chose AWS before. I don't know what happens if we choose Google Cloud. Give that a go. This is none in Australia. We can choose Singapore's pretty close. And we're just going for a shared RAM, 512 megabytes, M0 Sandbox. And we'll just call it cluster 0, no backup, and we'll create that cluster. So did anyone have any trouble getting their clusters set up? I'll be listening in the YouTube chat and also on the Slack channel, Learning to Code. Okay, let's see how our Colab notebook's loaded. Yep, that looks like it's come up. So yeah, we've discussed a cluster of databases as a bunch of the same database on several servers, so that if one goes down, you can use the other. It all happens automatically in the background, so you don't need to worry about that. What we're going to be doing today, we're going to use Mongo DB. In the past, we've used SQL-like and MySQL. and they're SQL databases. But MongoDB is what they call a NoSQL database. So they call it a document database. It's schema-less. It doesn't have a fixed structure, so you don't have to set up the schema beforehand. You just start putting documents into it. Okay, Leo says, took about 3 minutes. I guess that's for making his cluster. Yep. So a document in this database is really much similar to a Python dict or dictionary. And so MongoDB is really well suited for Python programming. We're going to look at the 4 main operations you want to do with a database, which are create, read, update, and delete. If you can do those 4 things, then you can do pretty much everything you need to do. And so that's why they call that a CRUD. If you've got all the CRUD operations worked out, then you've got everything that you need to know. So that's creating the records, reading, which is including filters, and so you can filter out particular parts of the database, updating, changing the data that's in the database, and deleting it out of the database. So we've created a shared cluster. We have to create it's not even working, I don't think. So I'll click on that again. But hopefully you've all done it. So then you have to create a database user, and give them read and write access to the database, any database. And then you have to whitelist your IP address. Now, that just means that we're telling MongoDB Atlas where we're going to be connecting from, but we're going to be connecting from Google Colab, so we don't know where that's going to be. So we just need to sell MongoDB to allow connections from anywhere. So where do the permissions go? Let's see how this is going. They go after you've set up the database. So you create the cluster first. I'll go back to AWS. That doesn't seem to be working. We'll do one in Sydney and create a cluster. Once you've created the cluster, it actually came up for me a checklist of things that we have to do, and these are pretty much the things: create the free shared cluster, create your first database user. So you create that, and then when you create the user, you give it privileges. So the privileges can be read-only, they can be read and write, or you can have also set up admin access. And admin access allows you to delete databases, and so that's really the only reason you'd need admin access. You can also set up a period of time. I haven't seen that sort of thing before, where you say this user will only be valid for 6 hours. And so if you forget to, if you don't do anything, the user just disappears after 6 hours, and that really reduces the chances of someone connecting to your database when you weren't thinking about it. And then next time you just have to create a new user next time you come along. And allow from anywhere. So if you're at home, you'll know what your home IP address is on the internet, so you can put that address in. But so you'd have to be using Jupyter Notebooks for that. If you're using Google Colab, you're connecting from Google servers. We don't know what the IP address is, so say allow from anywhere, and that's in the section that says whitelist IP address. Let's see if there's anything else I was supposed to select. Cluster 0, create cluster. Not getting much response there. Okay, and then the last thing, you should get your URI for the connection by the application. And that'll be something that looks like this. So most of this bit at the end will be the same. This bit in the middle could be different depending on which server you're on. And they've probably got groups of servers all over the place. And DFWZ3 is the one that I managed to create one on before. then gives a place for putting in username and password. And now the connection URL here, they're using URIs like HTTP URIs, where you put the protocol at the beginning. We're going to use the Mongo DB protocol. And when we're using this cloud version with Atlas, we put plus SRV in there. And what that means is that it uses DNS to get the DNS SRV records to configure your cluster, so you don't have to put the whole cluster configuration into the URI. So we've got some reference material here. Mongo DB is the database we're going to be using, and PyMongo is the library, the third-party library that we're going to use that allows us to connect our Python program to Mongo database. So I'll just open them in some new tabs. All right, so we have to, PyMongo comes installed with Google Colab by default, but not with the SRV options. So we use pip install with an exclamation out the front here, which means the exclamation mark says we're going to run a command line utility here, we're not running a Python command. And we're going to install PyMongo with the SRV extension. So if I press Shift Enter on this, hang on, I'm going to save it first as a copy in my own area, save a copy in Drive. And now it says copy of Meetup 078. And so now I can do changes to this one because the other one was a read-only one. Did everyone manage to get their Mongo database configured? Mine's not actually configuring here that I'm setting up, but the one I did last time before, that worked fine. So it says here PyMongo was already installed, so that's fine, but it needed DNS Python to also be installed, and that's because of this SRV requirement. Now here's the standard libraries we're going to be using today, so I've just put some import statements in for them. That's good, Peter. He's got his Mongo DB set up. That's great. The only third-party library we're going to be using is PyMongo, and so we'll import that one here. So I press Shift Enter. If you want me to run over some of the Google Colab stuff, I do it every week, but if you haven't been in previous weeks, feel free to ask questions and I'll go over some of how we're using Jupyter Notebooks in Google Colab. All right, if you didn't get to set your database up, you can use this read-only URI that I've set up. So you won't be able to do any of the things where we're creating or writing or deleting or updating, but you'll be able to do any of the filtering and reading exercises by using this URI. It's just a read-only one. So just uncomment that. I'm going to leave it commented because I don't need it. This is the URI I'm going to use. The DB name, we'll all use this one, DB Beginners Python and Machine Learning Meetup 078. You can call it whatever you like, but at least we'll know what that one is if you use that name. And the password, rather than me typing in my password so that everyone can see it, I'm going to put my password in a file called mongopw.txt, and I've done that, and I'm just going to upload that file into the into my uploaded files here on my drive, and then I'll be able to access that from the program. And so here I'll open the file to read and store the password into my variable password. So you can either create a file like this and upload it, or you can just type your password directly in your Google Colab here and get rid of these lines of code. Now once we've got the URI set up, we can we set up our client connection to the Mongo database, and it's just this pymongo.mongo client and the URI. Then we create a link to a particular database, and the way we do that, we refer to it within the client as client, and we can use a square bracket index notation, or we can use the attribute dot notation. So I could have called it client.db-_bpaml078, or I can call it client square brackets and then as a string the name of the database. Because we already had our database name in a string, it's useful to use this notation for specifying our DB now. This hasn't created the database yet, although because I've done these exercises before, that my database will actually already be there. But if we look at what database names exist by saying client.list database names, it shows me that there's an admin, a local, and a DB_BPAML078. Now you won't have that one yet because you haven't done anything. So the way PyMongo works is it doesn't create anything until it's actually been used in a particular way. See if our create cluster worked. No, it didn't, but I assume you all got yours working. Otherwise, I can spend more time on that if you need. Close that one. Okay, if you want to see how the SRV thing works, you can run these commands if you've got Mac or Linux, or you can go to online DNS tools like ultratools.com. So I'm just going to copy this. So what we've done here is we've taken cluster 0.dfwz3.mongodb.net out of our URI, and we've added to the front of it _mongodb._tcp. And we do a DNS lookup on that. And, sorry, it didn't copy. I pasted. Copy. Okay, so we've typed in that domain name, and here in the SRV, it's given us 3 records. So they're the 3 servers that will be forming our cluster. And then if we look at just the last part of the name and look at the TXT record, we'll see some extra configuration options that it puts onto the end of our URL as well. And that just means that our URI here can be a bit shorter because the rest of it gets from DNS. I'm going to start with a fresh slate, so I'm going to drop some collections that I've had from before. You guys don't need to run that one because it will already be there. And now let's have a look at what collections we've got within our database. So a collection is like what we would call a table in an SQL database. But tables imply a structured nature with column names across the top and rows down with the same columns on each row. We're just a bunch of documents, so they call it a collection of documents, and each document can be structured differently. So this says there are no collections yet, so we're starting with an empty database. So that's good. So how do we create some new data? We start with our DB that we defined before. Then we just use dot notation to our collection. So that's created an attribute called federal MP, and I just use CLCT as so that I can remember that's a collection. And straight onto that, we can use the dot notation to call the function insert1. And so the first time that PyMongo sees that, it will create the collection federal MP and then allow us to run this function insert1 on it. And what we insert is a Python dictionary. So it's just a bunch of keys and value pairs. So name is a key, Scott Morrison is a value, party is a key, Liberal Party of Australia is a value. Pythonator is my username in this Mongo DB here. So that's where your username should go. And that'll be the user that you've created that you've given read and write access. So company name was right at the beginning where you set up your user. But this is, sorry, where you set up the account name for Mongo Atlas. Pythonator is the connection user for MongoDB. I can try connecting again, see if it's a bit faster. Okay, so that's in, create a cluster. So here's the checklist. Build your first cluster, create your first database user, whitelist your IP address, load sample data. So I'm going to click on build a cluster. That'll do. Create a cluster, see if it works for me this time. Try Sydney again. There we go. 1 to 3 minutes to provision. It's all working a lot faster for me now. Yeah, so that's your username. Yeah, so you put in your own username there and your own password. And even here, you have to change this bit as well to whatever host name the MongoDB gave you. So you should get the whole URI from MongoDB Atlas and just fill in the bits and replace all of mine with yours because it could be different. Okay, so let's run this code. We're going to insert one record and we're going to look at the result that came back, and the result is going to have an inserted ID. Inserted one record and the ID was, and this really long number. So we've put that data into the database and it's given us back an ID we can use at any time we want to call it up. That'll be a unique ID within the database. Now we could have specified the ID as well if we wanted to, but in this case we'll let MongoDB generate our IDs for us. And now if we look at the list of collection names that are in our DB, we can see that it's created a collection with that name as well as inserting data into it. If we want to get data out, we can use find. So once again, db.collection.find, and that'll return docs, and then we can loop through docs and print each one. So let's have a look what that gives us. So there's the documents in the collection. The documents come out as a Python dictionary, just like this, name, party, position. And we also get this ID at the front, which has got the key value, the key underscore ID, and this value object ID, and this made up object, this unique ID. Now, so these IDs are object IDs. You don't have to use object IDs. You can just use strings. I think you can even use numbers as well. And just whatever you want to use. So we used insert1 to insert a dictionary. What other types can we insert? So let's try inserting a string and see what happens when we do that. So I'm going to insert a string. I'm going to catch any type errors that might occur. And if a type error occurs, I'm going to say we had an error doing the string and see what the message is that we get back from that. You can use the same database name I've used, db_bpaml078, or you can use another name if you like. Whatever you use, it'll just create it automatically for you. If I were you, I'd just use the same name as me. Okay, so there was a type error inserting a string, and when we print out the error message, it tells us what we can insert. We can insert dictionaries, we can insert bson, .son.son, we can do raw bson document, or we can do any type that inherits from collections.mutable mapping. So this bson is really like a binary JSON. So it can do JSON and it can do a few extra binary types as well. So it's actually better suited to Python than even to JavaScript, because JavaScript objects don't have those other binary data types that Python does. So an example would be a date-time object. We can store date-time objects exactly as they are, date-time objects, and they'll go into bson without a problem. In Python, in JavaScript, you have to use a string or an integer, but you can't store dates and times. All right, if we want to insert a bunch of records, we can put all our documents, our dictionaries into a list and store them. Now, our data types don't even have to be the same for each one. You can see here we've put position for Josh Frydenberg and Anthony Albanese, but Julian Simmons, we've just left position blank because we don't have one. Michael McCormack has a couple, so we can put them in as a list. And then we use the insert many. Insert many takes a list of dictionaries, basically, and returns the result, and we get all the inserted IDs that we get from that. So if I run that, it's now created 4 new unique IDs, each one corresponding to one of these records that we've put in. Now, to get all the data out, we can use find again without any arguments. So that's going to find all the records. And we can see that they've come out just exactly as we put them in, with these extra object IDs out the front. Okay, I'll see how my cluster's going. That's been created. Very good. Let's have a look at. So build my first cluster. That's been ticked off the list. Create my first database user. Click here to manage projects database users. And here we are. We'll add a new one. We'll just authenticate using password. We'll give the user, I'll call it Pythonator, which is my username that I want to use. Enter a password so I can auto-generate a secure password and copy that off and put it in my text file. And this is the privileges that someone was asking about. I can say read and write, I can say read only, or I can say admin. So I'll want read and write, and I can make it a temporary user for just 6 hours if I want. Restrict access, I don't need to do that, so I'll just say add the user. That's right. So yeah, use dbpm AML 078 as a database name, and you'll notice that when you first connect, that database won't have been created. Now it had for me because I had done some practice in that area, but for you, you'll just see admin and local until you actually do the first, create your first collection, and then it will put those, it'll create the database at that time. So network access, we add an IP address, and we want to allow access from anywhere, and that will do. And we can say this entry is temporary and will be deleted in 6 hours. Okay. And then the last thing is connect to your cluster. Once you click here to connect, let's have a look. Choose a connection method. We're going to connect your application. And here is an example of the URI. So you can see that's quite different. It's now mlicd, mongodb.net. Python8 is my username. It's got a spot there for password, and it's got a spot there for DB name. So you can copy that through to the to your Colab notebook that we had back here, and MDB URI. Put it in here. I've changed it to curly braces rather than angle brackets around password and DB name, and I've made it a format string, and that way I can just use the variables password and DB name to insert the correct values there. Okay. Any questions up until now? Good. So remember the last session we did on JSON data, we got some events data from Brisbane City Council. So today we might use that same data. So we'll just download it from that URL. And I'll print out what the first one looks like so we can see what we're working with. So the first one here, it's a dictionary. So it starts with a curly brace. It's got fields, all day, cancelled, category calendar, custom fields, and here are the values, true, false, and so on. And so the events comes back as a full list of these dictionaries. There'll be 200 of them in all. And to put them into a database, we can just use insert many and insert them and see what comes back. And we'll just look at the first 10 items that came back. So I've got 200 events sitting in my list, and that's inserted them in a very quick amount of time. And here's all the object IDs that are being created. Now, if I want to find the first one that was an all-day event, I'm going to create this filter here, and the filter is going to look once again like a dictionary. So Mongo really loves their dictionaries. And there's the key. I want the all-day value, and I want it to be true. So let's have a look what I get back when I run that. I store that in an event, and I'll print the event. I'll actually delete a couple of fields out, custom fields and description, just so the whole thing is not too big. But we really only want to just check to see that the field all day is true is what comes back. So you can see that's how I get data back out of the database. So we're doing pretty well. We've done the C and the R of CRUD. We'll keep doing some more R because we'll work out ways of pulling data out. So we could check the field all day, and that was true. We can also check the location field and pull out something that's at the Museum of Brisbane City. So what we're saying here is the location has to match that exactly. We have to get all of that in the location. So we create our filter, which is just that key and that value. So it's going to be an exact match. The result is going to be from using the find, and find we just pass it the filter. So filter is the first argument, so we don't have to use a named argument, and that will store it in result. So let's run that, and we'll have a look at some of what we get out, because here we're going to print out what the type of the result is. So we found all the Museum of Brisbane, Brisbane City. They're all the locations, so yep, they're all good. These are the titles and the descriptions. So that's all stored, that's all just displayed there. But the result of this find is actually of class cursor. Now what a cursor is when you're using databases, you use cursors because they allow you to step through the results one at a time without having to load all the results into memory at once. So it's quite a memory efficient way of handling it. And you can just use it as though it's a list coming back, although it's a bit different to a list because you can't run the loop twice. You run it once, and then the second time, so say we wanted to run this loop again for R in result. And I've used the else version of the for loop here. So you say for R in result, print this. Else, if there are no results, then do this, which is print no more once cursor has traversed the results. So I'm saying there's no more results there because the cursor has already gone through them. So that was how you would filter stuff if we had to do an exact match. But sometimes, and quite often, we want to find just a word in a string that's being stored in the database. So if we were using SQL-like or MySQL, we'd write something like this. Select star from table event, where location equals, and actually I think it should be location like, I think equals works as well. And then we use these wildcards, %city, %. And that means it can have anything before the word city, anything after the word city, but it's got to have the word city in there. And then we're going to order by location descending. So the way PyMongo does this is uses regular expressions. Now, regular expressions are a lot more powerful, as you would know from our regular expression session, than just simple wildcard characters in a string. So we can do re.compile city, and that matches anything that's got city somewhere in the word. So we can use regular expressions this way, which is re using the standard regular expression library that comes with Python, and compile that regular expression up and then just match it to the key. Or we can do it this way, which is using Mongo DB to compile the regular expression, and we use these nested dictionaries. So we say location, we want to find by a regular expression on CITY. And if we look at the MongoDB manual, you'll see here, let's have a look, we've got a reference for querying. I'll just see if I can remember where it is. Query documents, and we can choose Python. So once again, we can do field and then a nested dictionary operator value, and the operators can be, so as an example, like $LT we had $regex $or. And often when you're looking at the Mongo documentation, you'll see those operators don't have double quotes around them, and that's because they're using a JSON notation for people using JavaScript. But in Python, your keys always need to have quotes around them if they're strings, because they can also be other data types. In JSON, they're always strings. Okay. So we're putting in a filter. I've decided to use named arguments here in the find command. And so we're going to specify the filter, and we're going to specify the sort order. And so the sort order is a list of tuples. List of lists would probably also work. And each tuple is going to have a field name, and it'll be a pair, so it'll be a field name, and it'll be a direction. So if you want it sorting descending, you put in -1. If you want it sorting ascending, you use +1. And let's get the results from this. So this is everything that's in the city. And we've sorted by location. So it's put them all together by location. So these are all the South Bank Parklands ones. This is all the Roma Street Parklands. And it looks like we've got all the cities there. They all end in city, so can't really check if it worked for city in the middle of it. But I can tell you it would. There's our titles and there's our descriptions. Okay, so we're going to do our first task here. How would we find all the members of the Australian Labor Party using the original data that we created? So we can create a filter. And we put in the key, and we put in what the value is going to be. In fact, it's already been typed for me, so I can just use the variable party that's got that in it. And then I want to return all the results from that federal MP collection that satisfy that filter. So I'll give it the filter. Now that will give me a cursor. And party's not defined because I didn't execute this. So I'll execute the question, and then I'll execute that. And that gives me a cursor. And if I want to see, I can easily convert a cursor into a list just by putting it into a list like that, and then displaying the list because it's a Jupyter Notebook. And so it's given me the one item, one member of the Labor Party that I've got in my database, so Anthony Albanese. So you can see what I did then. That's how you create a filter. It's just a dictionary with the key and the value. And then you find with that filter, that gives us a cursor, and we convert the cursor to a list because a cursor is an iterable thing. Any iterable device you can create a list from, and then displayed the list. Or I could have done a for loop, as I've done in the solution here. I haven't stored the cursor. I've just put the find command straight into the for loop and then printed out each record as it comes through as I iterate, and there's only one. And there it is. Okay, find all members of the government. So that's the Liberals or National parties. If you looked at the original data, you could see that could be either the Liberal Party of Australia, it could be the Nationals, or it could be the Liberal National Party of Queensland. So one way of doing that is we can loop through all those parties. And then we can do a find and loop through all the results of a filter on those parties. And so the filter is just going to be the party name, party, and then print the result. Party is not defined. I've got to remember to execute the task cell. And there we go. It gives us all our Liberal parties of Australia, then all our nationals, and then all our Liberal National Party of Queensland's. Alternatively, Mongo DB provides us with a $in operator, which means we can provide a list of all the parties, and as long as party here is in that list, it will satisfy the query. And it's often better if you can move as much of the query into the database as you can, because it will run faster than when you write your program. So I had to do 3 queries here because I had to loop through doing a query each time. But if I can do this, running it all in the database at once, it'll be much faster. And I get the same results. The order can be different because this one was 3 queries run consecutively. This one is 1 query all run at the same time, so just whatever order they come out of the database. In fact, I can see here they're in order of object ID. So that's one way of doing it. The other way, we could have used regular expressions. So I just want the word party to contain somewhere in it the word liberal or the word national, and just use the regular expression, that pipe operator, which means or. And so if either of those match, then it's going to produce, give me the result. Now, in my results in this case, I don't want the ID to show. So what I've done is I've created a projection dictionary. Once again, MongoDB likes its dictionaries. And it said which fields that I want to include. So the ID, I've put a 0 against it. That means don't include it. But the name and the party I do want to include, so I've put a 1 against them. And so, yep, I've got name and party. I haven't got any object IDs coming back. And so that's where you would use projection. So here it is with named arguments, filter equals filter, and projection equals projection. Okay, so task 3, extract just custom fields from a collection event. So custom fields, we can use projection for that. So we don't want the ID. So ID will be there by default, so you have to specify that you don't want it. And all the other records, you have to have either all 1s or all 0s for the rest of them. So you put in here the ones that you want to include or the ones that you want to exclude, but you don't put include, exclude, include, exclude, include, exclude, except for ID. ID is the only one you have to say whether you want to include it or exclude it, otherwise it will default to include. So custom fields is what I want. So that'll be a 1. And then I want to find all the values in the event collection that have, and I just want to return those fields. Yeah, maybe not get any others. So, and I'll just convert that to a list. Now there's going to be a lot of them, so let's just look at the first 3. So I've got 3 records and the custom fields from each of those 3 records. So you can see here's the first custom fields, here's the second custom fields, and here's the third custom fields. So you can see these custom fields, they've been set up by someone who hasn't had the joy of being able to use a database like Mongo DB, because they've had to really stick to a fixed structure. So they've got field names, field ID, label, type, value, field ID, label, type, value. And really what they want to do is they want to use something like the label here as the field name, and then these values after that. I mean, field ID and label are probably very tightly linked, and probably type as well. And so it's really just, we want to see parent event, Brisbane Festival. This one wants to be event type, value wants to be art exhibitions free. Okay, so that's answered that question. Let's have a look at the solution. Alternative ways of doing this. Actually, I'll do another way I could have done for this. I could also have just provided, my projection could have just been a list of fields that I wanted to return. So let's do that. Yep, that worked as well. So it's fairly flexible. But it doesn't let you, using a list doesn't let you exclude, so you do get these IDs coming through. Or you could use the dictionary way where you can exclude the IDs. So what have we got? The first time I've done projection, turn off the ID, turn on the custom fields, print the first 10, that looks okay. The next one looks the same. Oh, and then I've created a list, an empty list, and then I've looped through and put all the custom fields into that one list, and then I've printed out the first 10 of the custom fields regardless of what record they're from. So let's run that solution. So you can see here the first test and custom fields lists. Each one of these has got several custom fields in it. So there's the first one, here's the second one of the first record. Here's the first custom field, here's the second custom field of the second record, and so on. But I could put them all into the one list, and so you can see here I've got 22503, 22505. So from 22503, 22505. And sometimes you want to do that, and that's called unwinding all the values in a list. These are requirements that you don't even have in SQL databases, but because of the nature of the data in MongoDB, you can have this. So they've got this using aggregate, you can aggregate several commands that happen one after the other. And here's some examples. You can unwind the custom fields, which is basically what we've done here. You can do things, you could match that particular custom field to a value. You can project, which means is your projection, which fields you want to keep or remove from the results. And then you can group them back up again. So in this case, if you wanted to group after you've done, you just wanted to find every record that had a field ID of 21859, but you wanted the complete record, then this is how you would do it. You would unwind the custom fields, match them to that record, and then group them back up again and reassemble. So custom fields using this push notation to take each of the individual custom fields that have all got the same ID and pushing them into a list. We'll just look at this one for now. So let's run that. So we're just unwinding and getting out the custom fields, and that's a very similar list to what we had before, 22503, 22505. And then we've just, so I've demonstrated here how you can loop through a cursor if you wanted to use a while loop for some reason. It's a lot more complicated than using a for loop, but if you really did want to do it, how a cursor works is that Each time you want to move to the next value of the cursor, you call cursor.next. So cursor is what we got back from our aggregate or our find from Mongo DB. So we just keep calling next. We get the next value, gets stored in R. And so here we can print the value of I and R. And we're in a while loop here, so we're just keeping incrementing I so that we can see what record we're up to. But there's no way of finding out when the cursors come to the end of the data, except that the last time you call cursor.next, it will it'll raise a stop iteration exception. So when it comes to that, when you get the stop iteration, then you can stop and print no more results in cursor. I would have thought we'd get something printed. Let's have a go. Okay, I'm not sure why it didn't print no more results in cursor. So printed it over here somewhere. Anyway. Oh, I know why. And it's because our loop is finishing when we get to 10. So let's see if we can so there's going to be quite a number of results from this this loop that we've got. So I don't want to be printing too much, so let's just go is the except needs to be an else. No, with this exception here links to this try. So try is catching when next throws the stop iteration, and except will show it. And so when it hits the stop iteration, it'll jump down to here. But we didn't get that because our loop stopped when I got less than 10. So it just went straight through to print the end. But I can make that if I is less than 10,000, and if I modulo 100 equals 0, print that, and let's run that. Oh, yep, Python syntax. There we go. So I've got 100, 200. So every 100, I'm printing out what the result is. And then it did throw an exception, no more results in cursor. And let's see what I was. What did I get up to? 1,647, and then the end. So as you can see, that's a lot more complicated than a for loop. So use for loops as my recommendation. All right, now we come to the U in CRUD, how to update a record. So let's say we want to add a field called division to the record of Julian Simmons. So we set a filter just the same way we've been doing it for find, and we set that. This time we're going to use update one. So we've been using, you can do find one or find. Find will find a whole lot. Find one will just return one record. Update one will just return the first record. Update will update all the records that satisfy the filter. We know there's only going to be one, so we could have used either in this case. And we're going to update. We're going to use this Mongo DB notation, $ and the operator name, which is set, and it's going to set the value of division to Ryan. That field could have existed previously, in which case it would have got overwritten. In this case, it doesn't, so it will get inserted field. So after we've done that, we'll print out all the results and see what we get. And you can see that Julian Simmons is now in the division of Ryan, but no one else has got a division. Okay, so we want to create a new description field with Unicode instead of HTML entities. So I'll just scroll back to where we've got some description fields. And here's some description fields. And if you look at this data, these things here where you've got ampersand hash 8217 semicolon, that's what's called an HTML entity. Now we want to convert them to what they are, and this will probably be an apostrophe. But it's a Unicode apostrophe rather than just a straight ASCII apostrophe, so that's why it's got this complicated number. So there's 8216, 8217, that'd be a left apostrophe, a right apostrophe. So how do we do that? So we could loop through all the records and find each result and update it. So for R in the event dot find, so we'll go for all of them. So let's create, we now want to update R. So to do that, we can use the update one command. You see there's an update many and an update one, and an update. I think update's been deprecated, so it's just been replaced by update many, just to remind people that it could update many if you run that command. So it's just a bit safer to use update one. We create our filter, which one we want to update. You can see here, filter, update, says what we want to update with. Upsert means if it doesn't exist, you want to insert it. So it's just a combination of the words update and insert. So if you want to convert an update into an insert, you say that to true, but by default it's false. And that'll do for now. So we'll work it out by ID. So we want the ID to match the ID of the record that we're currently in. And that's a good enough filter. So for our update, we want to set a new field, which will be called description raw. And we're going to set that to unescape the current description. Okay, so that's what the record is that we want to do, and we're going to use nested dictionaries. So we're going to tell Mongo DB what we're going to use. So we use the set operation, and these are the fields we're going to set as part of our update. So that will do it. And in fact, if you look down at the solution, that's pretty close to what I've got in the solution. In fact, I think it's identical. Oh, I forgot the dollar sign out of there. That should be $set. Description raw, HTML unescape. There we go, yes. Now, for the purposes of this exercise, we'll just run the solution, because what it does, it'll look at the first 5, and then it'll start a counter, a performance counter, and it'll do the update and then work out how long it took to do the update and then have a look at what the results were. So let's just run this here in the solution. So you can see started the solution here. It's taken the first 5. We can see here we've got some HTML entities there. There's another one there. Another one here. Another one up here. And it's off there doing all the updates. So it's got to update 200 records to do this. So we've got a start time. And then the finish time. So it took 42 seconds to update 200 records. Just while we're doing this, I might just share this. I've got to share this workbook. So you've got the original workbook that you can, but anyone who's, it won't have anything that I've typed in tonight. So this one, this share URL will be the one that I'm working on tonight, so it'll be this copy of. So if you need to, for some reason, find something that I've typed tonight, you can do that. Now I'll just share that on Slack, and I'll share it on Google YouTube chat. Anyway, so getting back to here, we've got 42 seconds to do that. Now that's quite a long time. It's only 200 records to update. But because we did them one at a time, it's 200 separate update transactions that had happened with the database. And PyMongo recognizes, and Mongo DB recognizes that when you have a lot of these records to do, that it would take a long time. So they create a way of doing bulk updates. I mean, you remember when we first created the data, it only took 2 seconds to create all the data, and here we were just updating it. We weren't even changing it that much, just adding one field to each record. So what we do is we create a list of things that we want to do, and in this case we wanted to update one record at a time. But rather than run it on the database, we append it into a list. So this is just a standard Python list I've created called list bulk. And then when I've finished putting those 200 items into the list, I call the one database operation, which is bulk write, on this list, and it does them all at once. So let's run this and see how long it takes. So there we go, it's finished already. 2.07 seconds compared to 42.59 seconds before. So if you're performance tuning your database operations and you're doing a lot of small operations, this is a really good one to look at too. And there's other things you can do other than update one. You can do find one and other things that are all. There's a whole bunch of classes for these in PyMongo that you can put into a list. All right, staying on the subject of performance tuning, another thing you can do is you can create indexes. And indexes work in all databases to speed things up. And they work out an order to search through results. And they can also enforce some constraints. So in this case, for example, we want to index on the name. So if we look up by name, it'll be faster. A bit hard to test that at this moment because there's only a few records in there, so it's going to be really fast even without an index. But we can test the constraint enforcement, which is we want the names to be unique. So we can create this list, this index here, which is just on the field name. It's going to be called name1 is the name of the index. And we don't even need to know that name because it's just there now in our database. And so now if I insert a new record for Scott Morrison, it throws an error. It says a duplicate key error. and I'll catch that error and I'll store it in DKE variable, and I can print DKE and it'll tell me I've got an E11000 duplicate key error, and the duplicate key is Scott Morrison, already exists. Okay. So you've got normally a search will, an index will just be directly on the contents of those fields, but they've got one which is really interesting. It's called a text search. And a text search will let you look for bunches of words that can appear in different places. They don't have to be all consecutive together. And it can also cross fields, so you just want somewhere in one of these fields you want the particular text is that you're looking for. Now you can only have one text index on a collection, so you have to include all the fields that you want included in that text index when you define it. So we create the index. It's just a list of tuples, and each tuple is just the name of the field and text, name of the field and text. And you can even put in a language that you want. It somehow uses that for plurals, I think, and that sort of thing. So for example, if we were going to look for any of our description raw that had the word myths, tales in it using regular expressions, what do we get? We get none. Okay, but now if we do a text search on myths, tales, and we get an error. And what is that? Text index required. I didn't define the text index. So there we go. It's created a text index, and now if I run that text index, it's searched through description raw and title, and you can see I've got myths and tales here, and that has been enough for it to find it. So I could even have, when I've done my search here, I could have called it tales and myths, and it still would have found it, even though in the text it's myths and tales. So a text index can be pretty useful, and it's not something you can do in standard SQL. Like I know Oracle has got some text searches that you can do on their databases like that, and they look for similar meanings of words as well. Okay. All right, so we did aggregates before, and here's another example of it using aggregate functions. So this aggregate function is how you would count, find the count of all the locations. I've only put in one thing in here, which is grouping. So group on location. So that's the $sign there is telling me to use the field name location and use that as the ID for the new records that it's creating. And I'm going to create a field called count, and what that's going to do is going to sum this value for every record. So that could have been a field I'm summing, but in this case I'm just going to sum the number 1, and I sum that number 1 the number of times the records that are, and that's going to give me a count. So this is an example of using aggregate to tell me how many times each location appears in the data set. Okay, and I've stopped it when I got to 20 records using the break command. But yeah, Toowong Library, there's 1. Roma Street Parkland, there's 13. Carina Library, there's 1, and so on. So it's just another example. So I hope you found this useful. Mongo DB is a very flexible way of doing databases. Databases are very fast ways of getting data out of storage. So whether that's on your solid state drive, anything that's not RAM based. I mean, even RAM based databases exist, but the database engine can return the data really quickly. It's just, I'm always amazed how quickly we're getting data out of that. So if you can get your queries to work in a database, that's the way to go. Not having a schema is a new way of doing things for me, and I can see it's flexible. I can see that data we've used from the Brisbane City Council, if we'd managed to design that without using a fixed schema, I don't know whether the schema was in the database they were using or in the XML that they were trying to produce, because they produce an XML version as well, then I think they would, if they'd had Mongo DB, then they would have found that much easier to design their data, the way they return their data, because they're using JSON and Mongo DB go really well together. When you're doing XML or SOAP or those sorts of structures, they go pretty well with your SQL databases. I mean, XML doesn't need to be as structured. CSVs definitely have to be structured, so they would use really, you'd link them to SQL databases. But JSON definitely goes well with MongoDB databases. It's used a lot where you don't know the final format of the data. It's also used where particular pieces of data belong to other records. So, for example, the events data we've dealt with the Brisbane City Council, those custom fields would have to have been stored in a separate table and then used a relation between the two tables. You've got to have your events table and your custom fields table, and to have that relationship set up. But really, nothing else owns that data. It's owned by the event. An event owns those custom fields. Nothing else would need custom fields data by themselves. So they can be stored in the MongoDB as a record. And so you've now simplified your data, the number of data tables you've got, and working with fewer data tables is always a good thing. It makes your programming much easier. So that's an example of somewhere where we'd use it. I looked on the MongoDB site. They had an example, was a doctor's surgery, and you're keeping your client's database. So you have a client, and then the client can have a phone number, but then sometimes clients have got two phone numbers because they've got a mobile phone and a home phone, and then some have got three. Do you keep creating extra columns in your structured database for up to the maximum number of phones that someone's likely to have? Or do you use something like MongoDB that flexibly can just increase the number of phones that they have and just label each one with some descriptor so you can identify them? Okay, any more questions? I'm just going to finish up now. You can look at, I hope you're able to run those examples with your own database. I think MongoDB is used quite a lot in mobile phone applications. So typically languages like JavaScript and Python work very well with that mapping data structures, and so they work well with MongoDB. Okay, thanks very much for your time. So next week we'll be looking at object-oriented programming. So we'll look at classes, and that's really it. We'll just deal with classes, and we'll just do a few examples with how to use Python classes. So I hope to talk to you next week.